There has been a viral rumor floating around that SpaceX is buying Cursor for $60 billion. That story is false, but it feels true because the engineering reality behind it is happening right now. The boundary between writing code and running inference on specialized hardware is collapsing inside your editor today. This video explains why an aerospace giant would need this capability immediately, and how you must rethink your career when your IDE becomes a node in your own inference pipeline. Let's clear up the confusion first because trust matters more than clicks. There are user-generated repositories labeled with SpaceX names that have 0 stars or forks. They are fan projects, not corporate acquisitions. No official announcement exists regarding a $60 billion deal between the rocket company and Cursor Technologies. However, if you feel this news is inevitable, it is because your workflow has already changed without you realizing it. The question for every developer is no longer about who owns which tool, but how high-performance engineering constraints are forcing us to treat our editors as active compute nodes rather than passive text files. We need to look at the hardware layer that makes this shift possible. When an AI-native IDE suggests a full function or refactors your entire codebase in real time, it is not just reading characters on a screen. It is consuming significant GPU cycles to run local inference models or querying cloud APIs where those tokens are billed per second of compute time. This friction between heavy local workloads and traditional development workflows proves that the IDE has become part of the deployment stack. The speed at which you can write code now depends entirely on how well your environment handles the latency of generating logic for silicon architectures you may not even own yet. Quick resource note. I keep a curated set of Amazon search links in the description for books, gear, and tools relevant to this channel's topics. Some are affiliate links, so I may earn a commission at no extra cost to you. Please consider supporting the channel by using those links if you find something useful. Consider why an aerospace company like SpaceX would need these capabilities, regardless of any acquisition rumors. In high-performance sectors, optimizing for specific hardware constraints is non-negotiable. You cannot simply write generic Python syntax and hope it runs efficiently on a flight computer or a specialized ASIC used in guidance systems. The code must be generated and validated against those unique architectural requirements immediately within the editor itself. This means the engineer's role shifts from writing pure text to orchestrating inference pipelines that produce architecture-specific logic. If you are not managing these trade-offs, your workflow is already slower than it needs to be because you are treating the AI as a spell checker rather than an infrastructure partner. The industry data supports this move towards specialized hardware literacy. While specific acquisition numbers remain unverified fan fiction, the adoption of tools with over 176,000 stars and more than 21,000 forks shows that developers are already voting with their time on these platforms. The statistics tell us where the community is going, to environments where code generation happens faster because the system understands the target hardware deeply. This convergence means that as you type, your editor is not just completing syntax, it is predicting how that logic will interact with underlying GPUs or TPUs. You are no longer writing for a human reader in isolation. You are generating instructions optimized for silicon that might be embedded in a satellite or a launch vehicle before the file even saves to disk. This creates a fundamental shift in what skills matter most for your career development. The fear is often about learning AI prompting versus mastering hardware architecture, but those two paths have now merged into one critical competency: infrastructure literacy within the IDE. You must understand the trade-offs between latency and token costs when deciding whether to run an inference model locally on your machine or send it to a cloud provider. If you are running local models to generate code for embedded systems, you need enough GPU VRAM to handle the context window without stalling your terminal. Conversely, if you rely on cloud APIs, every suggestion becomes a line item in your operational budget that scales with your traffic and complexity. The friction is not just about syntax generation anymore, it is about managing the compute cycles required to produce valid logic for complex systems. When an AI suggests code optimized for a specific architecture, it reduces the time you spend translating human intent into machine instructions, but only if you understand where that optimization stops being beneficial and starts becoming fragile. This requires knowing when to trust the generated output and when to intervene with architectural constraints that the model cannot see on its own. The engineer of tomorrow is not just a writer, They are a system architect who manages the flow between human intent and machine-generated, hardware-optimized logic. We are moving from writing code for humans to read toward generating logic optimized for silicon that does not exist yet in your standard development environment. This shift means you cannot rely on traditional coding skills alone. You must understand how your editor consumes resources and how those resources translate into the reliability of the software you deploy. The IDE is no longer just a text editor. It is the first node in your inference pipeline, and treating it as such will determine whether you can scale your engineering output or get stuck waiting for suggestions to load while your team waits on delivery. The future workflow belongs to those who treat their development environment as an active participant in system design rather than a passive recording device. By understanding the hardware constraints that drive these AI tools, you secure a career path where technology augments your judgment instead of replacing it. This is not about being replaced by automation. It is about mastering the infrastructure layer that makes modern engineering possible at scale. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.